Heinemann Higher, Chapter 4, Trigonometry, Graphs and Equations. Question 5, exact values of angles greater than 90 degrees. Because you know your exact values for the acute angles, the 30s, 60s and 45s. Well, so what we do with this? Well, first of all, I'll define where does 315 end up? Now, I could use the graph, but I think I'll just stick with that cast diagram, the all sine, tan, cos, and figure out from the positive x, where does 315 end up? So if I spin round 315, I'm going to end up here. I'm going to end up with 45 degrees left in a quadrant where only the cosine is positive, which means that the sine of 135 is equal to the sine of 45, because that's the acute angle I'm left with, but in a place where the sine is negative, so negative sine 45. And then it's just a case of what is the exact value of sine 45? Well, you may well remember it exactly, I could write it down, or you could reconstruct a triangle. The 45 triangle is the simple one, half a square, which is 1, 1, so Pythagoras makes that root 2. So the sine and the cosine are both 1 upon root 2. Leaving it in that usual form, which has got the certain denominator, rather than the giveaway when you use your calculator, and you get a root 2 upon 2. B says, what is the exact value of tan 7 pi upon 6? Well, this time 7 pi upon 6. Now, you can either try to think in radians or just transfer that into degrees. If you try and think in radians, then you'd have to think, well, that's 0, halfway round would be pi, and if you're talking about sixths, that would be 6 upon 6 then. So 6 sixths would take you halfway round. So 7 sixths must mean you're 1/6 beyond that. So that means that 7 sixths must be the same as pi upon 6, all sine, tan, cos. The tangent's positive where you've ended up, so that was okay. So it's the same as tan pi upon 6. Or you could have changed that all into degrees, and that would have done just the same thing. 7 pi upon 6, 7 times 180. 180 divided by 6, 7 times 180 divided by 6, that goes 30, so that's 210, so that's 30 degrees beyond it. So it's the same as tan 30, whichever way. But 30, well, you've either learnt them by heart, or better, just remember the construction of these two triangles. The 30-60 triangle is half of an equilateral triangle. The simplest sides would have been 1, 1, 1, but since you're halving one of the sides would be 2, 1. So 1, 2, root 3, and I'll put 30 there, or in radians, pi upon 6. So pi upon 6, the tangent is 1 upon root 3. And I'll be positive 1 upon root 3. C. For part C it says, what about cos of negative 150 degrees? Same again, where's negative 150? That means I'm going to spin back through 150 degrees. So spinning back through 150 degrees will leave me here. Spin it back through 150, there's 180 altogether, so that leaves me 30 degrees in that quadrant. All sine, tan, cos. So I've ended up with it being the same as cos 30 in a place where only the tangent's positive, so that means the cosine's negative. And I've already got my 30 triangle there. The cosine of 30, that's the adjacent one, is root 3 upon 2. So I've got negative root 3 upon 2. There's the values.